Wanted Excel. And the speed should be the ortho with zoom. Well, the ortho with zoom acceleration. And that should clamp it with 0 and -1 as well. So if enough time has passed, we're going to change our acceleration. Okay. Otherwise, we need to LARP our zoom acceleration towards 0. So go towards the direction we want because it's been long enough. Otherwise, try to slow down and go to 0. So, God, this is all just a fucking mess. Anyway, I need to take a very short break. I'll be back in a couple minutes. So I will be right back. And then we'll get back to doing this camera stuff. We're basically making it ease. So let's get back to it. We are introducing our zoom delay and our zoom acceleration, and now this would be a lot easier to code out if I knew exactly how I wanted the camera to move, but of course I don't, so I'm kind of thinking about it, and that's why I'm like, I haven't written a freaking camera like this before, actually. Usually we just had like a 3D camera or whatever on our object, and just throw it over the shoulder. Fuck it, This is a little bit different because if it's 3D, it's much easier to do a 3D camera, to be honest. If you've got the collision stuff proper, it's a lot easier for me at least, because you can do a whole bunch of vector math and all sorts of crazy stuff, and it's much. At least I have more experience doing it, so. But 2D camera, especially with this sort of motion, is a little bit tricky. It's not just. You have to do all the things. I'm trying to think back to if I ever did any other cameras that are similar to this. The closest would be my sophomore year game, but that started as 2D and went to 3D, and we had some fucking problems with that. Which is why we went to 3D to begin with. Alright, so our zoom delay start is going to be there, and what do we want to do? If our acceleration is positive, so it's basically like we need to know if we can zoom. So it's pretty much like speed equals 0. So if zoom acceleration is greater than 0 and not zooming in, then speed equals this. Else if zoom acceleration is less than 0 and we are zooming in, like we can just do this sort of thing right here and just basically say, well, speed equals this, and then we just take fmath, absolute value of zoom acceleration here. So basically, if we're actually going towards the thing that we should be able to go to, then go ahead and do it. Now the question would be, should we stop? So zoom acceleration is going to start in one direction, and if it's actually in one direction, that means that your velocity has been changing, but it's been mainly in one direction, so we're going to allow you to zoom out. Or if you're already zooming out, and then your velocity changes are the same. So if you were going super fast, and then like your velocity now goes from 0 to maximum speed every other frame, you're still going to be zooming out. So okay, this makes sense. And basically zooming in equals now zooming in. Well, I have no idea if this is going to work or not. So let's find out. Zoom delay and zoom acceleration are just unused, so we can get rid of them. Alright, let's do it. Let's see what it does. Yeah, nobody's watching game development on a Monday. They're just like, fuck this, go to work. Especially not C++. So, our zoom speed is 0. Our zoom speed is... still 0. This is us not zooming. Ever. Alright, well, that's completely wrong. Why are we resetting our clock? Zooming in is false. Last camera width is less than M camera width. Well, I believe it's not. Our M camera width is 6000. Why? Well, its last camera width is M wanted camera width. So our wanted camera width is always this correct 6000. It's if our actual camera width yeah, so it's the opposite. It's if our M camera width is less than that. So do we need our last camera width? Our last wanted camera width at all? Or are we just basically saying like if there's a difference in what we want? So maybe we can just get rid of that entirely. Phone didn't work at all. Yeah, I'm not a Twitch partner, so I don't have all the fancy bells and whistles to make it actually work better on the phone. Also, shouldn't you be sleeping, Karakin? Okay, so let's see. So the zoom acceleration is 0, the wanted acceleration is -1. Your delta t was tiny, so shouldn't but can't. Yeah, I know that feeling. So we're zooming out. Our zoom speed is now 0. Our zoom speed is 1000 and 0. So we're running, and then we start to zoom out. And then we start to zoom back in. Yeah, okay. So if I'm just kind of messing around, nothing really happens. But if I'm running and jumping, if I just kind of sit still for a little while, it'll kind of zoom me in. So what if I just jump around a lot? Nothing too big happens if I jump around a lot. I'll slowly start to zoom out. If I just kind of chill out, don't do much. Yeah, so that seems to be kind of working for me at least. So if you just leave it alone, the camera kind of will zoom in nice on your character, otherwise it just doesn't. So the question is if I'm like trying to jump up a wall here, if it zooms back in. Because we don't really want it to zoom back in, we want it to just kind of stay where it is. And if I just chill out, it'll zoom in for me, and I can yeah, and then it nicely zoomed back out a bit. Not too much because I wasn't like full blast on it. Well, that works. Alright. So let's try to clean that up a little bit. Kind of complicated logic for just doing zooms, but well, zoom's gonna zoom. So I just do calculate zoom speed. Call to calculate our zoom speed. What is this? Calculate camera width. Yeah, so we didn't need that. at all. So the width offset should just be 0 vector, and we can actually remove the width offset entirely. A close up and zoom off into the distance. Well, we'll see. We can always mess around with some of that. Let's make sure we can have a well-behaved camera before we have a bored camera. Lead offset, camera position. I want the width offset. Didn't need it. The camera already does that. We don't have to do it ourselves. Alright, so it looks like we've got the zooming in and out working as I would like. So now we're gonna have to work on the other stuff. So we'll just do that. Reorganize it just a little bit. So it's basically saying, like, calculate the speed that will actually zoom. The speed is got a base and acceleration and all that. That seems pretty good. So we're probably going to have to do the same thing with all the other pieces and parts, so that's what we're going to have to do. Alright. Alright, let's see what it is. Alright, so everything's working as it should. Yep. Yeah, that stump is all sorts of screwed up. It's all wrong. Alright, well I'm pretty happy with that. So let's start on the next piece of it, which is our camera direction. Yes, we'll have all the things. So our camera direction right now is like this. Which is just, like if I walk back and forth, it's just awful. So we need to do the same thing. We need an acceleration towards the location. Basically, the screen should be either moving left or it should be moving right. And it should have a delay and do exactly what we already did. So we need a zoom acceleration and a zoom delay, but it's not called zoom, it's called camera direction offset delay. I believe we're starting to move camera forward direction change. And camera direction offset acceleration. And we're again going to set both of these to 2. It's kind of interesting just how many chunks of this thing I have to deal with. So this is going to be the direction offset, there's going to be calculate, offset speed, offset move speed. So we're gonna need same sorts of stuff. So width offset. Didn't we get rid of this camera width offset variable? Why did it come back? So we need our direction offset, and we're going to need M. Whoops. It should be called our offset move delay start, and our bool M moving left, or float M offset move acceleration. Offset moving left. Offset move delay start. And let's get that level time. So we basically want to do the same thing here that we already did. So it's going to be now moving left, and it's going to be if our current camera offset direction Y is less than our wanted camera direction Y, then now moving left is true. And we need to set our speed inside of these things because we're actually using our camera data. So offset move delay start. We need our camera direction offset acceleration. Zooming in is over this. I think it's this one right here. Y diff, let's just call it difference, equals this. Current camera direction offset minus, we don't need to shortcut this at all. Offset move delay start, now moving left does not equal offset moving left. If now minus offset move delay start is greater than ortho with zoom delay, we want camera direction offset delay. So if it's been longer than that, if we are moving left, wanted acceleration is -1. If we're moving to the right, wanted acceleration is 1. So it's not going to be the camera move speed, it's going to camera direction offset speed. So if zoom acceleration is greater than 0, and now zooming in, it's not now zooming in, it is now moving left. Now moving left, so it's going to be M offset moving left equals this. And we're going to call calculate offset move speed. We're going to set the speed up there, and it's going to be calculate offset move speed. delta T speed. Well, let's see if that actually does what we want it to. Basically what this should do is when we turn our direction, it should wait a couple seconds and then move our camera over at a faster and faster rate. Until it's there. And if we turn back around, or if we're flapping, like we're turning left and right real quick, nothing should happen. We should stay where we are. So if we are looking right, we should still be looking right. If we're looking left, we should still be looking left. At least that is the theory. How's it going, Adam? I see you're lurking there in chat, and everything seems to be fixed. Yeah, I don't know exactly what was going on there. If you get a whole bunch of like connection issues, let me know with that. Like the I know that's what I had last week. I had kind of a couple days there where connection drops were happening and things weren't able to check out. But if it's just like Unreal's not able to check something out, the only thing I can think of is like, you know, the workspace isn't set or Perforce wasn't open. And like Perforce uses a login ticket system where if your ticket is expired, like your ticket is used by other programs to access Perforce. So if the ticket's expired, then other programs might have, you know, they can't do a Perforce operation, but think they can. So if we're looking in a direction, and then we switch our direction, it's like totally screwed, isn't it? It's just very slowly moving. Probably adding to the wrong variable or something. Yeah, zoom acceleration. We got the wrong stuff going on here. We want not zoom acceleration, but the offset move acceleration. It's just one of Twitch's Spotify playlists. The Newgrounds music that I threw on there, I didn't really have too much of it, and some of it looks like is copyrighted or whatever. It's not like Newgrounds respected any copyright laws on all of its content back in the day. So I'm just kind of avoiding some of that. So we should zoom in properly and look to the right. Well, let's see. Yeah, I can actually pull this up a little bit right now. Basically what I'm doing right now is setting up all the camera values. So if I remove the direction offset, This is the camera as it is right now with just it's just got zooming right now. So if you're not doing anything, it goes to its default zoom, which is this one. And if you're active, it'll zoom out to here. And then if you just kind of chill out and do nothing, it'll, well, I have to actually chill out and do nothing. It'll kind of zoom in after a while. And if I'm, yeah, you see, even though I'm just like jumping around, it gives me a little bit more to work with. And we're doing a lot of little things like that. The next thing is the direction offset. Which basically is us, when we look left or right, it's gonna, you know, give us a little bit of screen space on that side or the other. So I have to figure out what's going on with that. And what I was using as kind of a reference camera was I pulled up Fancy Pants Adventures and was looking at kind of what their camera did. So if you want an example of what I'm going for, you can pull that up. But I think it's a pretty good example of, you know, if we can match that camera, then, or get, you know, close, that's a good starting point for us. Yeah, if you've never played Fancy Pants Adventures, like you probably have. I mean, hasn't everyone? Yeah, 2D. Yeah, of course. Yeah, I was like, of course you have. There's no way you haven't. So our camera direction offset is the Y there is less than the Y there, which is true, so now moving left should be true. If the absolute value this should be now. The absolute value is less than tiny float is false. Now moving left, offset moving left. Alright, so offset acceleration should be going to 0. Right, okay, good. So it should be 2 seconds, and then we should be offset acceleration is negative. It should be positive. Now moving left. Wanted acceleration is 0. Is negative 1? Like, wanted current camera direction offset is less than wanted. This is wrong. This is now moving left. This is the opposite. Now moving left would be if the current is greater than, so like, yeah. Question is, have you played it? I have not played the Bitey level. I didn't play that much Fancy Pants Adventures. Like, you'd think we'd have played more, since, you know, we had it there in the office and all that crap. But Mark was always so fucking negative about that game. Like, not in like a he hated it way. in like a he just wanted it to be better way. At least that's what I remember a little bit. So our wanted acceleration should be positive. So if we turn around, it should just... Why is it not doing what I want? Offset acceleration is -1, so offset acceleration... Zoom acceleration, yeah, okay, zoom acceleration is being used again. Yeah, a lot of copy pasta errors. There we go. That should have it solved. And yeah, it was basically with that camera, with Fancy Pants' camera, it seemed like it was just always behind the player, and like it was pretty simple in terms of how it worked. Basically was, can the camera move in this direction? If so, try to move in the direction. And there wasn't too much going on. The biggest thing there is the camera doesn't move very much. I don't feel like it looks that great. The leading is really obnoxious. Maybe it would look better if we actually had a little bit of foreground to kind of figure out where we are. Maybe it's tuning. I don't really like how componentized it is. Like, that the camera, like, very obviously is, you know, it's stopped moving and it's doing these like other little motions that are a little bit too componentized. So you can see like it's moving left and right, but like when it's moving left and right and zooming, you can see it kind of floats a little bit in there as opposed to what you'd really want. It's kind of like, you know, trying to get there, but it's like zooming over and then moving, and it's like, why didn't it just go to where it needed to be? You know, like, shoo. Yeah, moving camera is fine. It's just the parts need to move. So like if it's zooming in, it needs to zoom kind of as you would expect, instead of you know, making the picture smaller while moving it and then kind of floating in, kind of like a curveball would move into a strike zone. It needs to go straight there as opposed to float in, which might I'm not really sure how the hell to fix that. It might just be that what I need to do is kind of disconnect all this stuff a little bit. Because I've got the right coordinates, but it's that the camera is moving. Maybe what I need to do is the easing stuff should all be in basically the a different part. No. What's broken is the offset's broken. The offset's broken because when we're zooming in, his position on screen is changing. His Y offset is not in screen coordinates. It's in actual coordinates. So when you're zooming in, it's moving the camera wrong. That's why it looks weird. So the camera offset should be set in the problem is we're actually moving the offset Y and Z towards this, and what we should be doing is we should be instead moving the we should be moving in screen space and then calculating where that is at every frame. I usually have an eye for bad transformations. So that's what was bugging me. I was like, something's wrong. Alright, so let's just make sure our current camera offset is in the correct space. So we have current camera directions. So all these should be in screen space, not in world space. So we're just double checking that they're all in screen space to start with here. Our speeds are going to be like totally fucked up, but that's okay, we can tune them. So let's make sure we actually look proper. Because what was happening is as this was zooming, our like offset vector was changing, and this thing was like trying to get us over to this offset vector that kept changing, which is not what we want. We want the offset vector to lerp in screen space, and when we move, it should just when we zoom out, at least, what should happen is